the recording? It's going. We're live. Here we are. So things you may assume. In geometry, a lot of things look like certain things, but you can't just say they are. In geometry, you kind of have to prove everything. So some things that you can assume are that lines are straight. That's not much of a earth-shattering assumption. Lines are straight. Lines are straight. What else can you assume? You can assume that lines if lines intersect, they intersect at a point, which is kind of weird. They intersect at a point. What else? Intersect at a point. Points on a line are collinear. Points on a line are collinear. So these are the only things you could really assume. So you can't say, it's more important that you look at things you cannot assume. Okay? So if you look at these two lines, what appears to be true about those lines? They look parallel, but you can't assume they're parallel unless they actually mark them up or they say these lines are parallel. So you may not assume parallel lines, parallel lines, perpendicular lines, perpendicular lines, and congruent segments or angles. Okay, so just because two shapes look the same, or they look like something, you can't say this is a this because it looks like it, okay? They have to either tell you explicitly, or you have to prove it, or you have to, or they have to have markings on it, okay? For example, okay, here we go. Oh, did I go too fast? You want me to go back? Anyone want to still keep writing it down? It's not a big deal. So it's more important that I never really talked too much about this, but parallel lines, you can't assume things are parallel unless they tell you that. Perpendicular lines, congruent segments. So going on, okay, what shape is this? What shape is that? It looks like a rectangular. What shape is it, Trevor?
Quadrilateral?
Yeah, because I know it looks like a rectangle, and I drew it using my rectangle tool, okay? But unless it tells you that this is a rectangle, or you're given certain properties of it, you do not know it's a rectangle, okay? So it's just, this shape is just according to what you're given, it's just a quadrilateral, okay? Because you know it has 4 sides and that's about it, all right? So that's all you know that thing is. You get that? Okay. How about this shape? What shape is this? What shape is that? Why is that a rectangle, Ryan?
Because it has the markings for the right angles.
Yeah, it's got the markings for the right angles, and I don't think as we discover properties of quadrilaterals, which is in the next chapter, okay, we'll learn if it does have 4 right angles and 4 sides, we'll learn that you can prove that it's a rectangle. But in this case, you're given those are right angles. So this one is a rectangle, okay? Because you're given that those things mean it's got 4 right angles. Get that? Okay? How about this one? How about this? What shape is that? What shape can you say it is? You can just say it's a triangle. Who wanted to say it's an isosceles triangle? Did you want to say that? Because it looks like both, isosceles. We'll talk more about that in a minute, right? But unless they put marks on it, okay, like here and here, right, you can't assume that those sides are the same. Likewise with this, if I said, okay, if I put this mark here and this mark here and this mark here, then I could say it's something else, right? Is it a rectangle? We're going to play with that a little bit. I don't know. We'll talk about that in a little bit. Okay? So, moving on. In the diagram below, which pairs of lines are perpendicular? Okay? So, who can tell me, based on the markings, which lines are perpendicular? So, we're looking at this one, right? This is the only one that looks like they're perpendicular. Which ones are perpendicular? Which ones are perpendicular, Cadence? Can you see from way over there?
Yeah. ST and...
No, we're looking at this picture.
Okay. IM and KQ.
That's a J.
Oh.
JM and what?
KQ.
Perpendicular.
Oh. JM and JK.
Yeah, so the only ones you could say are perpendicular are JM and JK, right? So you could say that line JM is perpendicular to line JK. JK, I know, I'm telling the truth actually. JM perpendicular to JK. Because this one, you don't know for sure. It looks like it's perpendicular, but it might be going, more like, like this. It might be on a slight up, right? So you don't know for sure that those are perpendicular. Who can tell me which lines are parallel? Raise your hand. Here. Which lines are parallel there, James?
A, B, and C, D.
The only one you could assume here is that AB, right? Line AB is parallel to CD. Whoops, that's a line. Even, that means parallel to. I talked about this, didn't I? So that CD, so even though these ones look like they're parallel, you can't assume that unless it has like little, arrow thingies on it like that. Who can tell me which ones are congruent? Which, out of these three, who can give me a congruent statement based on the marking? Let's call this one stew. Triangle stew is congruent to something. Triangle stew is congruent to another triangle. What's the other triangle that congruent? Go ahead, Kareem.
XYZ.
XYZ. Is that the right order? S, T, U, X, Y, Z. That is correct. Okay? X, Y. Do you understand why? Because, right? Because S goes with X. Y goes with T, right? Because it's got 2 marks, it's got 2 marks. And Z goes with U because it's got 2 marks. And notice too that side ST has 1 mark on it, and here side XY has 1 mark on it. And side TU has 3 marks on it, and side YZ has 3 marks on it. So those match up. And all 3 parts have to be congruent. So that's the only thing you can say. This one looks probably like it's more congruent to this than that one is, but you can't assume it. You can't assume it because it doesn't have 3 sides that are congruent to 3 sides over here and 3 angles, because that's really what you have to prove congruence. And make sure you name things in corresponding order like that. Questions about that? Anyone? Okay then. So moving on, what are we doing next? We're going to do this. On the provided note sheet, discuss with your group. They come up with a good definition for each type of triangle on pages 60 and 61. Okay? So I'm gonna pause here. Pause here. Where's my pause? Pause. Pause. Triangle. Give you a valuable bonus. Oh, who'd I give the valuable bonus point to in the first place? Who's the first? Who put that? Who told me that number 23? Right now, James. Did you tell me number 23? Who told me about how to do number 23? Was it you? The one. Who's going to give me a good definition of a right triangle? Go ahead, Kira.
A triangle with 90 degrees.
Yeah, that's okay. A right triangle is just a triangle with a 90-degree angle. That's pretty much it. Okay, triangle with a right angle. Can I call it a right angle? Right angle. And when you make a sketch, whoops, am I recording? Oh, I wasn't going. There's a right triangle. Okay. Who can tell me what a acute triangle is? Go ahead, George.
A triangle with 3 acute angles.
Very nice. Okay. A triangle with 3 acute angles. Okay, so all angles are acute. You can't have and you could draw a picture of one of those ones that you have in your book, or you could draw your own. I have. Let's see if I can do that. No, that doesn't work. I have my freehand drawing tool. Where's my toolbox? Watch this. Where's my freehand shape? I could do this, and then I could go up. That should make a triangle. There we go. And then you could put in some numbers, like maybe this is 37 degrees, or what's that? 27 degrees. And maybe this is 75 degrees. And maybe this is 75, 80, what's that, 92 so far? 88 degrees or something like that, okay? You kind of know already probably how many degrees are in a triangle. Who knows how many degrees are in a triangle? Go ahead.
180.
180. Yeah, so we don't know that yet, but we're going to discover that. All right. Okay, who can tell me what an obtuse triangle is? Oops, who gave me that first answer? Parabole. And then George gave me the second answer. And my pencil's out of juice. Who's got the third answer for me? Go ahead, Drake.
A triangle that has one angle over 90 or an obtuse angle.
Right. A triangle that has one obtuse angle. And an obtuse angle is angle. Why can't I have more than one obtuse angles? Why, Kate?
Because they're all equal 180.
It wouldn't, and plus it wouldn't make a triangle anymore, right? So if you tried to, watch, if I tried to, where's my freehand shape? Freehand shape. If I try to make a triangle that has more than one obtuse angle, it wouldn't connect, right? So it has to be like something like this, right? So there's a obtuse triangle. Maybe this is 100 degrees, or you make up a number. Scalene triangle. Scalene. Who just gave me that last? Okay. Well, I gotta pick on someone on this side. Johnny.
A triangle where all sides are not equal.
Very good. Okay. No. You have to say a triangle. A triangle with no equal sides. Okay, or congruent sides. And so the way I could draw one of those, freehand shape, I gotta put that on my toolbar, freehand shape. So I could do something like, just, you could do something like this. This side is different than this side, which is different than that side. Yes, sir. Oh, the next one. Okay, go ahead, Kareem.
A triangle where all sides and angles are equal.
Very good. Okay. Equilateral triangle. It really means all sides are equal, but you might see that all angles are equal as well. So an equilateral triangle is a triangle with 3 congruent. Do they have a picture one of one that just has 3 congruent angles? So really all we know at this point is that it just has, we'll just say that even though we know that it's going to have 3 congruent angles as well, at this point we're just going to say 3 congruent sides. And I have an equilateral triangle tool, I think. Do I? The equilateral triangle tool? Something that looks like an equilateral. Does that look like an equilateral triangle? Now it does. Okay? And you can do that and bring it over here. I'm going to mark it up. Boom, boom, boom. And the last one, someone on this side. Someone on this side. Okay, go ahead there. You have no girls want to raise their hand? Okay, go ahead, Trevor.
Triangle with 2 but not 3 equal sides.
Nice. Okay. So an isosceles triangle is a triangle. Well, it looks like from that picture that one with 3 equal sides is an isosceles triangle, right?
Oh.
So is an equilateral triangle isosceles? Is an isosceles triangle equilateral? Not necessarily, right? So so to clarify Trevor's definition, I would say a triangle with at least, okay, at least 2 congruent sides. I'm going to abbreviate congruent sides. And you can draw a picture of an isosceles triangle. Let's draw one. Whoa, there we go. And to indicate it that it's isosceles, you go like this, you go like this. And these things in an isosceles triangle, those things have a name, okay? Well, those don't, these things are, this is called the base down here. And these things are called the base angles. Base angles, the 2 sides opposite the congruent sides, that's a base angle. And this is a base angle. And this thing up here has another name. They call that the vertex. So just when you know what they're referring to with an isosceles triangle, the one side in between the 2 congruent sides, or the one angle in between the 2 congruent sides is the vertex, and the 2 angles opposite those 2 congruent sides are called the base angles, and this piece down here is called the base. All right? So, now, since it's a block period and I want to give you some time to work, you're going to start the first part of your homework, okay? So, where'd my PowerPoint go? So the first part of your homework is part 1, page 62, 1 through 12, and 13 through 19 now, okay? So you can stare at parallel sides, right? So a trapezoid is a, I'm not going to write, well, I'll write the first time, I'll write quadrilateral with 1 pair of parallel sides. Parallel, sorry my writing's not that great, okay, side. So, and if you're going to sketch one, you're going to have to freehand shape, freehand shape, freehand shape, boom, 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 boom. Is that going to make one? Kind of, oh look at that, it worked. And then trapezoid. Who's got a definition? That was Cooper, right? Who's got a good definition of a parallelogram? How about a girl? Kate.
A quadrilateral with 2 sets of parallel lines.
Very nice. Okay. So that's a quad. A quad with 2 pairs, right? 2 pairs of parallel. I'm going to start abbreviating. That means parallel side. And if you're going to draw one of those, I think I have a tool that draws parallel. Do I? I don't know. That's not going to draw parallel. I think I have to use my go again. So something like that, and then you would indicate that this side is parallel to that, and then maybe put one mark here and one mark there to indicate that those are parallel. Okay. How about a rhombus? Who's got a rhombus? Who's got a rhombus? Ryan, how about James? Go ahead.
Quadrilateral with two pairs of parallel lines and four congruent sides.
Yeah, so if it's got two parallel sides, it's already a what? Parallelogram. So you could just, once you define something, you could use that to define something else. So you could say it a you can say it's a parallelogram, right? A parallelogram with all congruent sides, or with four congruent sides. All right. So, and you can draw a picture of one of those. I think. I gotta get this rule into well, let's see, that'll make it. Not really. Let's try that again. Go. Let's try again. That looks better. Okay. So make sure to run this. Boom, 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 boom. And we will learn later on that if we will be able to prove that if the four sides are congruent, then it automatically makes a rhombus, but we don't know that yet. We're just using that in a definition. Okay? How about a kite? Who's got the kite? So anyone on this side got the kite? I got you already, Kate. Go ahead, Dan.
Multilateral with two pairs of congruent sides that are adjacent to each other.
Yeah, okay. A quad with two pairs of adjacent and congruent sides, right? Is that kind of what you said? Yeah. And so you got to be careful with this one, because if you look at what are not kites, a rhombus cannot be a kite, right? So, those two sides that are adjacent to each other cannot all be the same, right? So a kite looks something like this with this and this, and let's see if that kind of makes a kite. Okay, so this congruent to this, and this congruent to that, but this cannot be equal to that. Okay, let's jump ahead to rectangle. I have these out of order. Rectangle. Who's got a rectangle? Did you have a definition for a rectangle, Elise?
Quadrilateral with two sets of parallel lines and all 90-degree angles.
But use the word parallelogram, because now you can use it. It's so what's something called with two parallel sides? A parallelogram with what?
All 90-degree angles.
All 90-degree angles, or all right angles. Okay? And I think you know how to make a rectangle. I even have a shape for a rectangle. I can make it, but you do have to indicate that it's a rectangle, showing that those are 90-degree angles. And probably too, at this point, we want to indicate that those sides are parallel as well. And finally, a square. Go ahead, Whitney.
A quadrilateral with all congruent sides and angles.
With all, oh, nice. So that's one way to define it. A quad with all congruent sides and angles. Because if they're all the same, then they would all have to be 90 degrees, right? You kind of know that, okay? But how about using some of those other terms? Go ahead there, Trevor.
A rectangle with all congruent sides.
A rectangle that's also a what? What's something called with all congruent sides?
Parallelogram.
Not a parallelogram. A rhombus, right? A rectangle that's a rhombus. You could do that, right? So you could say a rectangle that's a rhombus. So there's lots of different ways to say that, okay? So your definition, I'm sure, is fine. A rectangle that's a rhombus. A rectangle that is a rhombus. That is a rhombus, or a rhombus that's a rectangle, or something like that. So you know what a square looks like, I think, right? Square. That's a square. We don't want it to be filled in. No fill. How do I get no fill? This? I don't know. No fill. I don't know. None. There we go. Okay. Here's a square. It still came out red. Oh well. However you want to do it. There's a square. And oh, it's making lots of squares. Far out, man. Alright. Square. There's a square. Indicate it's a square with some marks in there. Boom. 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 There's a square. Okay? We're going to run out of time. I'm not going to do the little investigation that I was going to have you do, because I don't think we have time. Well, maybe we'll skip the line design for another time. Why don't we do this for just a few minutes? This is easy, okay? It seems threatening, but it's not. Just go. Where's my next PowerPoint page? Go to this. I want you guys just to go to this site right here. There's a link to this on my Schoology, or you can just type it in like that and play with each shape and tell me what they are. Okay, you know what? So go to you can either go to my Schoology, there's a link under today's assignment to this, or you can type in that code, and I want to try to do this little investigation, okay? So let's try that for a second. Okay, so that's the second part of your homework. That's on the quadrilaterals. And then I'll talk about the line design. The line design, man, I'll make you do like on Monday or Tuesday or block day or something. But I want to show you some cool stuff with the line design. Okay. Yes, ma'am. Two different isosceles. Oh, that's a tough one. Two different isosceles triangles, right? With a perimeter of 4. So if this is an isosceles triangle, right? You could call this 2A and that 2A and that B, right? 4A. But then you have to figure out another way to do it. Did anyone figure out another way to do it? So that as this is number 8. How could I draw another isosceles triangle that is different than that one? You could call like this side 2A plus B. Oh, that won't work, will it? You could call maybe this is B over 2. This is B over 2. And this could be 4A or something like that. That's one way to do it. But that's kind of the idea behind that. Because you don't know how long A and B are. Nice question. Yes, sir. Oh, wait. I have to get. Who gave me a good definition for quadrilaterals? Raise your hand. Who gave me? Elise. Who else gave me a good definition? James. Who else gave me a good definition? Ben, I remember. Who else gave me a good definition? Kate. Okay. Anyone else? I think Trevor did too, right? Questions, problems? I want to go get a yardstick so that I can show you how to do the line. The last part. You want to learn how to do that? Okay. You want to get a compass. I'll be right there. Hey, you guys, I'm going to show you how to do line design. The line design, I'm not going to make it do, we can make it do like Tuesday of next week or something, okay? So, but I want to show it to you, so you can work on this, this homework that you're working on now will be due tomorrow, but I kind of want to show you the line design thing because it's cool, okay? So if you go on page 8 of your book, it shows you how to make one of these, which is called an asteroid, okay? You do that on graph paper, it's a common. And you just kind of connect, you start with graph paper and you connect one dot to the next. It'll show you in your book how to do this. This is a Sierpinski triangle. Have you heard of those before? You make a triangle and then you connect the midpoints and then you connect the midpoints and the midpoints and stuff like this. This is kind of, they show you how to do this design that looks like this, and they show you how to do this design, which is kind of what I did up there, okay? So to do this kind of design, I want you to do one design, pick one You could do a combination of several of those, but the key thing is that it's got to be made out of straight lines, okay? Straight lines. And do it on a nice white sheet of paper. I have some here, and color it in and make it look beautiful. And if you do a really good job, I'll give you a couple extra credit points, okay? But I do want you to do it. But to make this design, basically the idea behind it is you would use a straight edge. So I'm not going to do it in the interest of time. I'm going to try to go fast. But basically you start at a vertex of whatever shape you start up. Triangles kind of work best. But you start with a vertex and then you move over a little bit. And from that corner, you move over a little bit. And then wherever you end, you keep moving over a little bit. Like that. And then you get this twisty kind of three-dimensional looking thing. Like that. That looks pretty cool, right? And if you want to make it overlap itself, then you draw another triangle. And you could draw another triangle. And you could draw like more triangles and make it look cool. Okay? Like this. I have some really cool ones in my classroom. So if you want to make 6, I just want to show you really quickly how you make a hexagon. We'll do this more in your when we do the constructions. But to make a hexagon, you start by making a circle. You don't have to do this, but you start by making a circle. Okay? And then you do not change your compass, and you pick any point on that circle. So you start there and you move over, and because of the properties of equilateral triangles and that there's 360 degrees in a circle, if I keep that same setting, basically you get this 1, 2, 3, 4, 5, 6, and if you connect that to the midpoint, you get 6 equilateral triangles. See, I know I went really fast, but if you do that and you put that pattern inside, it looks really cool. Okay, so you could try to do something like this, or something like this, or something like that, or something like this, or something like that, or that, or that. But make it nice, okay? And put it on white sheet of paper or graph paper. I was going to have you start in class today, but I don't think we'll have time today. But I'll give you plain white paper. It's just typing paper if you need it. And it has to be done with a straight edge. You can't just do it freehand like I did. And I have graph paper and white paper up here if you want to grab some on your way out. Okay, but that won't be due until, we'll make it due next block day, okay? So the line design, don't worry about it for right now, but maybe next block day, just work on the homework. And those are in your book on page 8. Okay? And I posted this PowerPoint too. This one isn't in your book. Okay? I kind of learned that my 3rd year of teaching. Some guy from India taught me how to do that. Shri. He was the funniest guy, Shri. And he went to Dartmouth. He was so smart. He would have his kids do line design. Oh, I never gave back that algebra quiz? How much time do I have? I have 5 minutes, I can give it back. If you bomb that first algebra quiz, you want to redo it, you can. Okay, but you have to see what you got wrong. I'll give it back now. So, Cadence, Ryan, Samana, Johnny. So I have to redo that that looks a lot like this if you wanna do it, just to bolster your grade up a little bit. You can make it up through next week. You can come to tutor time. Matt, David McGovern, James. But you can come and get some help from me too. Where's James here? George, back here. Green, Ashley, Trevor, Evelyn, Drake, oh, you're not, sorry. Yes. Cooper, Jackson, Gabby, Abigail, she's in here. Iron Plum is up here. Elise, nice job. Kay McCormick, Kenyon Smith, Jack, what's Jack? Jack, Ian, Ben, wait, Ben, I gave you someone else's, right? Did I give you someone else? Yeah, this is yours. That's not yours. This could be yours. That's gotta be someone else. Yours. Whitney. Sophia. Jane, and so if you bonded, come and get some help. I'll go over a few things with you, and you can redo it if you want. Okay? My design's not to do until next block day, and the homework those two little assignments I gave you are due on Friday. Okay? Is it time to go? It's 9:09. It's 9:09 or 9:08. Okay. I can't let you leave yet. I have to remember to do my hall duty because I keep getting in trouble because the principal's checking up on us. And if we don't do our hall duty, we get deep duty. Yes. Okay, you can go now. Bye. Have a nice day. Bye.
So you circle that so she knows that that's supposed to be.
Oh, I don't think I took off Times Square. I don't think I did. Wait, the action.
Yeah. So you got that one on.
Yeah. Okay. See you guys later.